Find the derivative of function 3x to the third power minus 4 over x squared. So for here, we can actually rewrite this part to 3x to the third minus 4x to the negative 2 power, so that we can apply the power rule. So we take the derivative by power rule, we get 3 times 3, 27, x to the second power minus 4, let's multiply negative 2 times x to the negative 2 minus 1, which gives us 27x to the second plus 8x to the negative 3 power, which we can rewrite as 8 over x to the third. So this is the derivative of this function right here. Find the derivative of function 4 minus x squared to the third power. So here, this entire thing to the cubic power is the outside function. And this right here is inside function. So when we take the derivative, we first take the derivative outside. So we're using chain rule. And for the derivative outside, we use power rule. 3, the entire thing to the second power. But then inside is 4 minus x squared. That's the argument. But then we do have to multiply by derivative of the argument. Like this. So now the next line, this one stays same. And here we take the derivative. So for derivative for each of these, we use power rule. Derivative 4 is 0. Derivative constant is 0. So this is 0. Derivative minus or negative x squared is by power rule. We get negative 2x. Then we can simplify this. We can multiply negative 2x and 3. So we get negative 6x times 4 minus x squared, entire thing to the power, raised to 2 power. So this is the derivative of this function. Find the derivative of e to the sine x. So here, e to the some power, this is the outside function, and inside function is sine x. So when we take the derivative, because it's a composite function, we have to use chain rule. We know that derivative of e to the x is e to the x, but in this case the argument is sine x, so we just leave the sine x here. But then by chain rule, we have to multiply by derivative of the argument, which is derivative of sine. So then, if we take the derivative of this right here, sine x, which is cosine, our final answer is e to the sine x multiplied by cosine x. So this is the derivative of this function. And note that cosine is not an exponent. So it might be useful to write it like this to avoid any confusion. Cosine x times e to the sine x. We can also rewrite it this way, since in multiplication, order does not matter. Right? So either of these is fine. So this is derivative of this function right here. Find the derivative of natural log of x plus 2. So here, because inside is not just x, we do have to multiply by derivative of inside. So we do have to use chain rule. So when we take the derivative of f of x, we get 1 over whatever the argument, which is x plus 2. And we have to multiply by derivative of the inside, or derivative of the argument. But here, this derivative also, or not also, derivative of this is 1, which doesn't actually affect compared to like 1 over natural log of x. But regardless, we are applying the chain rule because this is not, argument is not just x. So final answer is 1 over x plus 2 times 1, which is just 1 over x plus 2. So this is the derivative of natural log of x plus 2. Find the derivative of x squared times cosine x plus x times tangent x. So for here, for each of these, we have to use product rule to find the derivative for each of these. Product rule, because these are a product. X squared times cosine x, x times tangent x. So each of these are product. So when I find the derivative of this, let's write in product. So derivative of x squared times cosine x plus derivative of cosine x times x squared. So this is just for this portion. So this is the derivative of this. Then for this one, let's write it here using different color. Plus derivative of x, applying the product rule again, times tangent x, plus derivative of tangent x times x. So on the next line, let's just take the derivative of each of these. So let me highlight here. So we're taking derivative of this, this, and this. So here we get, using a power rule, 2x times cosine x. Derivative of cosine is negative sign. So we do minus sine x times x squared plus derivative of x is 1, so we just have tangent x, plus the derivative of tangent is secant square x, so secant square x times x. So this is the derivative of this function right here. Now, quick note here, we cannot combine this to x cubed. Okay, so don't make the mistake. This is sine x times x squared. We cannot just multiply these x's together. Same here. This is secant square x times x. We cannot just multiply x just to x here. X is multiplied the entire function of secant square. Find the derivative of square root of 3x squared plus 2. So here we have a composite function. This is the outside function, and inside function is 3x squared plus 2. So for square root, it's useful to write in half power so that we can apply the product rule. So let's find the prime or derivative. F prime is, first we apply the power rule for the outside function. So half times, 1 over 2 times 3x squared plus 2. Make sure to keep the parentheses here. 1/2 minus 1. Multiply by derivative of inside. So 3x squared plus 2 prime. So when we use prime notation, it is important to note that this is prime, not like a 1 power. Okay. So then next line, we get 1 over 2. 3x squared plus 2 to negative half power, since 1 over 2 minus 1 is negative half. Multiply by this gives us, by power rule, we'll get 6x, and derivative of 2 is 0. So when we simplify, we can write 2 times this right here can come down to the denominator and half power, so we'll get 3x squared plus 2. And here's 1 times 6x. But we can multiply actually 6x to 1 here. So we can just write it 6x. And this one actually can simplify one more step. You see this 2 and 6 gets simplified to 3. So our final answer is 3x over square root of 3x squared plus 2. So this is the derivative of this function right here. Find the derivative of x over 4 times sine inverse of x. So this right here is sine inverse, and this is x over 4. So we have to use product rule. Right? So let's write out the derivative first, and then we'll find each derivative. So derivative of f df dx equals derivative of x over 4 times sine inverse, right? This is sine inverse, not 1 over sine. This is arc sine, same as arc sine, plus derivative of sine inverse x multiplied by x over 4. So let's find the derivative of each. So we're finding derivative of this and derivative of this on the next line. So right here, this is x over 4, we can think as same as 1 over 4 times x. And since the exponent is 1, we can multiply 1 here, which is 1 over 4, and minus 1 gives us 0 power. X to 0 power is 1. Therefore, derivative of this is just 1 over 4. So 1 over 4 multiplied by sine inverse x plus derivative of sine inverse is 1 over square root of the entire thing, square root, just on the denominator, 1 minus x squared multiplied by x over 4. So let's write the final answer in the next line. Derivative is, so you can combine this, we can write it as sine inverse of x over 4 plus, we can rewrite this right here as x over 4 times square root of 1 minus x squared. So this is the derivative of this function right here. Note that we have to use product rule, and we also have to know the derivative of sine inverse. Now here, we have 4 times the square root, right? It is more conventional to write this 4 in the front, because if we don't do that, if you just write this, it is easy to get confused and make mistake by saying 4 is actually under the square root, right? So either you can do this, or just conveniently write 4 in front of the square root. So, but it's not wrong to write it this way. But usually, if we multiply a number to a square root, we put the number in front of the square root. Find the derivative of e raised to 3 minus x power. So here, we have e raised to 3 minus x power. So e exponential function, e to the x is the outside function, and 3 minus x is the inside function. So when we take the derivative, first we take the derivative of e to the x, so which is e, keep the same argument, just 3 minus x, multiply by derivative of 3 minus x. So multiply derivative of argument, because we're using the chain rule here, because this is a composite function. So then we have e 3 minus x multiply by derivative of 3 is 0, derivative of negative x is negative 1. So final answer, we can rewrite this as negative e to the 3 minus x. So this is the derivative of this function right here. Find the derivative of arc tangent x. So arctangent is tangent inverse. So note that this is the same thing as tangent inverse. Sometimes we write inverse this way. So here, we need to know derivative of arctangent x. And derivative of arctangent and derivative of arccotangent are the only inverse trig functions without square root on the denominator. So derivative of this is 1 over 1 plus x squared, the argument square. And of course, if argument is not just x, for example, let's say argument was x to the cube, then we do have to apply the chain rule. But here, chain rule is not necessary because argument is just x. Find the derivative of square root of 9 squared minus sine squared x. So here we have a composite function. The outside function is square root, and inside function is this 9 squared minus sine squared x. So when we take the derivative, we do have to use chain rule. And we can also rewrite this as half power. And inside is 9 squared minus sine squared x. So let's take the derivative. df dx equals, first we apply, we get this as an outside function, power rule for the outside function. Okay, negative half power, inside is 9 squared, and we can write it that as 81. If you want, it doesn't matter. But we do have to remember that derivative of 9 squared is 0 because it's constant. And that becomes important when we multiply the derivative of inside right here. So then by chain rule, we multiply the derivative of the argument 9 squared minus sine squared x. So let's write the next line in the step. So here, derivative of 9 squared is 0 because it's constant. As it's important that 9 squared is constant, we can, if it's easier for you to see, this is equal 81. Derivative of 81 is 0. Right? There's instantaneous rate change is 0. Now for negative sine x squared, we do have to use, there's two ways. We can either use chain rule or we can use product rule. Either one's fine. Okay. So the way we can look at it is we can see that we have sine x entire thing second power. Then we can use chain rule, or we can see it as sine x times sine x. But then we can use product rule. Either will give us the same answer. So I'm going to do the chain rule. So let me write down this step. Actually, what I'm going to do here, I'm going to rewrite it. This is a negative exponent. I'm going to bring the denominator. So I have 1 over 2 and half power is square root. So square root of 9 squared minus sine squared x. And multiply by, let's keep it in parentheses. So we have minus, let's apply the chain rule here for this one. 2 times sine x to the 1 power, multiply by, and you don't have to write this 1 if it's confusing, just don't write 1. Multiply by derivative of sine, which is cosine x. Okay. So we apply chain rule here. Again, you could apply product rule as well, and we'll still get the same result. So then final answer is we can multiply this entire thing to 1 right here. So we have negative 2 sine x times cosine x over 2 times square root of 9 squared minus sine squared x. And these 2's cancel out. So we have left with negative sine x times cosine x, entire thing over square root of 9 squared minus sine squared x. So this is the derivative of this function right here. Find the derivative of arc sine of 3x. So here we do have a composite function where inside is 3x and outside is arc sine. So we know that derivative of arc sine is 1 over square root of 1 minus the argument square. So in this case, the argument is 3x, so it would be 3x squared. But then since it's not just x, since it's a composite function, we have to multiply by derivative of inside function because we're applying the chain rule. So then the derivative, well, we can simplify. Derivative of 3x is 3, so this is 3. So we have 3 times 1, the numerator 3, over square root of 1 minus, this is 9x squared. So this is derivative of arc sine of 3x. So we do have to pay attention here that we're applying chain rule here, because 3x, which is an argument, is not just x, right? So 3x is composite into as an input for arc sine x. Find the derivative of find the derivative of 2 raised to 5x squared plus 1. So this is the exponential function with base 2. So we do have to remember the derivative of, let me write it here, derivative of, let's say a is a number raised to x is a to the x times ln of a. But here we don't have just x, we actually have 5x squared plus 1. So we have to use chain rule. So derivative of this is first 2 times 5x squared plus 1, just copy it as it is, multiply by ln of 2. Then the argument, which is the inside function, is 5x squared plus 1. So we have to multiply by derivative of that function, like this. So then we get 2 5x squared plus 1 times ln of 2 times derivative of this is 10x by power rule, and derivative of 1 is 0. So this right here is the derivative of this function. And this is as simplified as we can make it. We cannot just multiply 10 to 2 here. ln of 2 is a number. So we cannot further simplify here. Find the derivative of ln of 5x squared minus 8x plus 3. Here, when we take the derivative of natural log is 1 over whatever is inside. But then here, because not just x, we have to multiply by derivative of this by using chain rule. So first, we have 1 over this entire thing, 5x squared minus 8x plus 3. Then we have to multiply by inside, derivative of the inside function, like this. So then we have 1 over 5x squared minus 8x plus 3. And we multiply derivative of this, which is 10x by power rule minus 8. And yeah, we can multiply these two numerator here, combine to one fraction. So we have 10x minus 8 over 5x squared minus 8x plus 3. So this is the derivative of this function. Find the derivative of negative sine x times cosine x over 2 plus x over 2. So here, this one, we can think this as actually negative half times sine x times cosine x plus 1 over 2 times x. Those are equivalents. And the reason we do that is so that we actually don't need to use quotient rule here, because we can think of it as this constant multiplying to sine x times cosine x, which allows to use product rule. So for this one, we need to use product rule. After we use product rule, we just multiply negative half to that derivative. And this one, derivative, we just use power rule. So let's take the derivative. So df dx equals negative half times, let's see, by product rule, derivative of sine, which is cosine, times cosine x, plus derivative of cosine, which is negative sine x, multiplied by just sine x, plus derivative of half times x is just half. So let me simplify it a little more. This one we get cosine square x minus sine square x plus half. And we can actually distribute negative half, so negative half cosine square x plus 1 over 2 sine square x plus write a little better, so sine square x plus half. So this right here is the derivative of this function. Find the derivative of e to the e raised to negative x squared power. So here we have a composite function. We have negative x squared as an argument for the outside function e raised to something, so e to the x. So when we find the derivative of this, we get e to the same argument multiplied by derivative of negative x squared, which we get e negative x squared times negative 2x. But again, usually when we have something like this, we write negative 2x in the front, because we don't want to ever confuse that negative 2x is an exponent or not an exponent. It is not an exponent, right? So this is the derivative of this function. Find the derivative of cosine x times tan raised to sine x. So for this one, we have to use first product rule, because we have two functions multiplying. Product rule. So let's write out the derivative first using product rule. So it says derivative of first function times just the second function as it is, plus, let me actually use different color for second function, tan to sine x, plus derivative of tan sine x multiplied by first function cosine x. So derivative of cosine is negative sine, negative sine x, just multiply by tan sine x. And then for this one, we have to use chain rule. Okay. So first of all, derivative of tan raised to x will be just 10 or ln. Well, let's actually, first we need to copy what it is first, right? Then multiply by ln of 10. Then we have to multiply by derivative of sine x using chain rule here, times cosine x. So what we end up getting next line is negative sine x times 10 to the sine x plus 10 sine x, 10 raised to sine x times ln of 10. Now derivative of sine x is cosine x. So we have cosine x times cosine x, which gives us cosine square x. So this right here is the final derivative of this function. So here we have to use product rule first, and then we have to use chain rule one time for this portion right here. Find the derivative of negative 1 over 4 e to negative 2x minus 1 over 2x times e to negative 2x power. So here, for this one, we're going to have to use chain rule when we find the derivative. But here we have to use product rule because we have two functions to multiply, x and e to negative 2x. So let's take the derivative. So negative 1 over 4 is just constant, so we can multiply negative 1 over 4. And derivative of e to the negative 2x is first just e to the negative 2x multiplied by derivative of the argument, which is negative 2x. Minus, let's give it minus 1 over 2. And we can multiply negative 1 over 2 afterward. So let's apply the product rule. So derivative of x times e to negative 2x plus derivative of e to the negative 2x times x. So next line, let's simplify more. We'll take the derivative of each component, this one, and this one. So negative 1 over 4 e to the negative 2x multiplied by derivative of negative 2x is negative 2 multiplied by negative 2 minus 1 over 2. Derivative of x is 1 times e to the negative 2x. Now here we literally took the derivative of the same thing right here, right? Which was this. Well, we can do it again. Plus derivative of that is negative e to negative 2x multiplied by negative 2 by chain rule times by x. So let's simplify here. We can multiply negative 1 over 4 and negative 2. We'll get positive half. And we can rewrite this as negative 2x e to negative 2x. And we distribute half. Negative half. Oh, sorry, this should be minus 1 over 2 e to negative 2x. And negative half times positive. Negative half times negative 2 gives me positive 1 times x times e to negative 2x. Now here, these are the same thing but different signs. So collect like term, these two cancels out. So only thing we have left as final answer is this one, x e to the negative 2x. So this is the derivative of this function right here. Find the derivative of 1 over 2 times arc sine of x, entire thing raised to the second power, plus e to the 5. So here, derivative of e to the 5 is just 0 because it's constant. So only thing we really have to worry about is right here. So when we take the derivative, here we have to apply chain rule. The outside function is this right here. The inside function is arc sine x. So first we apply chain rule. So we do 2 times 1 over 2. Entire thing to the 1 power. Arc sine of x. Multiply by derivative of arc sine of x. Like this. So then this one just cancels out. So we have, this is just arc sine to the first power, which is just arc sine. So arc sine x multiply by now derivative of arc sine of x, which is 1 over square root of 1 minus the argument. In this case, argument is just x, so argument square, x squared. So the final answer is, we can write this in the numerator, arc sine x over square root of 1 minus x squared. So this is the derivative of this function right here. Find the derivative of 10 times sine 2x times cosine 2x. So here we have to apply product rule first, because we can see two functions are multiplied. So let's apply the product rule. So df dx is, we can multiply the 10 later, is constant. So let's apply the product rule. So derivative of sine 2x times cosine 2x plus derivative of cosine 2x times sine 2x. So now we're taking derivative of this and this right here. But for each of this derivative, we have to apply chain rule, because argument is not just x, it's 2x. So then derivative is 10 times the entire thing. Derivative of sine is cosine. So we have cosine 2x. We keep the argument, but then we multiply by derivative inside. Derivative of 2x is 2 times cosine 2x plus derivative of cosine is negative sine. So we have negative sine. Keep the argument 2x. We also put the parentheses here just to avoid any confusions. Multiply by derivative of 2x. Derivative argument is 2 times sine 2x. So let's simplify a little bit. Here we have cosine 2x, cosine 2x. So we have 2 times cosine square 2x. Since we have 2 of same thing, we can square it. We can write a square. Minus 2, and also sine 2x, sine 2x. So sine square 2x. And now we can distribute the 10 here. So we have 20 cosine square 2x minus 20 sine square 2x. So this right here is the derivative of this function. Find the derivative of 1 over 2x squared times ln x minus 1 over 4x squared. So here, for this right here, we have to use product rule first, because it's a product, x squared times ln x. And here we just use regular power rule. So let's take the derivative. So product rule. So let's see. Another way we can also think about this is we can also think that this is a one function. We could take 1 over 2 as an entire constant. We can also think that this is a one function, first function. This is the second function. So we can take the derivative of 1 over 2x squared times ln x plus derivative of ln x, natural log of x, times 1 over 2x squared. Minus, this one we can take the derivative, which is 2 times 1 over 4 x to the 1 power. So let's take the derivative here. This one will be just x, because 2 times half gives me 1, and minus 2 minus 1 is 1 power, times ln x, plus derivative of natural log of x is 1 over x, times 1 over 2 times x squared, minus, this gives me 1 over 2 x. So let's simplify. We can see one of these x cancels one of these x. So we have left with 1 over 2x minus 1 over 2x, which these two cancels out. So only thing we have left is x times natural log of x. So this is derivative of this function right here. Find the derivative of arctangent of 10x. So as we know, the derivative of arctangent is 1 over 1 plus the argument square. Again, the derivative of arctangent is arccotangent are the only inverse trig function derivatives that do not have square root on the denominator. So arctangent is 1 plus argument square. But when argument is not just x, we have to apply chain rule. So first we write 10x here, and we have to multiply by derivative of inside function like this. So then we get 1 over 1 plus 10x, which is 100. 10x squared is 100x squared. Multiplied by derivative of 10x is 10, which is 10 over 1 plus 100x squared. So this is the derivative of this function, arctangent of 10x. Find the derivative of function natural log of tangent x. So here, when we take the derivative, we have to apply chain rule because inside function is tangent x and outside function is natural log. So first, when we take the derivative of natural log, the outside function, we get 1 over whatever the argument. But then we have to multiply by the derivative of argument, which is derivative of tangent x, which we get 1 over tangent x times secant square x. Derivative of tangent x is secant square x, which we get secant square x over tangent x. So this is the derivative of this function, natural log of tangent x. Find the derivative of x over x plus 1. So here we have to use quotient rule. So when I take the derivative, we can think as this, well, this is the numerator function, this is the denominator function, right? Or top and bottom function. So when we take the derivative of quotient, we do bottom function square, and we take the derivative of top function times just the bottom function minus derivative of bottom function times the top function. So this is the quotient rule. So then we can take the derivative of, so we're taking derivative right here and right here. Derivative of x is 1. So the only thing we have left here is x. Use different color. X plus 1 minus derivative of x plus 1 is also 1. Derivative of x is 1. Derivative of 1 is 0. So we have minus x. Entire thing over x plus 1 square. And we can simplify. We can see that x and this x cancels out. So we have 1 over x plus 1 square. So this is the derivative of this function right here. X over x plus 1. Find the derivative of arctangent of x over x plus 1. So here we do have to use chain rule. But first, we do have to apply the arctangent derivative because that's the outside function. Arctangent function derivative tells us that is 1 over 1 plus the argument square. The argument here is x over x plus 1. And we multiply by derivative of the argument by chain rule. So now for this one though, we have to use quotient rule for the inside. We have to use quotient rule. So let's do that in the next line. So we have 1 over, let me actually do it here. 1 over 1 plus x over x plus 1 square. Multiply by, now let's write the derivative. Derivative of top, which is 1, times bottom function, minus derivative of bottom, which is also 1, times x, over x plus 1 square. So that simplifies to 1 over 1 plus x over x plus 1 square. multiply by, let me see. So numerator here is just x. Oh, x cancels out, so actually just 1. So it'll be 1 over x plus 1 square. So derivative is just x over x plus 1 square. We can write in one fraction. Let me do it this way. This entire thing multiplied by x plus 1 square, like this. So this right here is the derivative of this function. So we have to apply chain rule and quotient rule here. Find the derivative of arc sine of x squared minus 1. So when we take the derivative, first we have to take the derivative of arc sine because that's the outside function. And because we're using chain rule, we have to multiply by derivative inside, the argument function. So derivative of arc sine is 1 over square root of 1 minus argument square, whatever is inside, square, entire thing square. Multiply by derivative of inside, which is x squared minus 1. So when we take the derivative of this right here, we get 2x by power rule. So our final answer is 2x over square root of 1 minus x squared minus 1 square. So this right here is the derivative of arc sine of x squared minus 1. Find the derivative of log base 3 of secant x. So here we have to remember derivative of, in general, derivative of log base a of x is 1 over x times natural log of the a, or base number. So here we do have to apply this, but we have to apply this and chain rule because this is inside function is secant x. So let's take the derivative. We get 1 over, in this case, argument is secant x. So we have secant x times ln of base number, which is 3. This 3 right here. And we have to multiply by chain rule, derivative of secant x. Derivative of secant x is secant times tangent x. So that's secant x times tangent x. And we can simplify. You see that this secant cancels out. So only thing we have left is this tangent x over natural log of 3. So this is the derivative of this right here, log base 3 secant x. Find the derivative of cosine inverse of x to the 6th power. So when we take the derivative of cosine inverse, if it were to be just x, it would be negative 1 over square root of 1 minus the argument square. In this case, argument is x to the 6th power, so x to the 6th square. But because this argument is not just x, we do have to multiply by the derivative of inside, derivative of the argument, because we're using chain rule. So let's just find the derivative of x to the 6th, which is 6 times x to the 5th by power rule. So now our final answer is negative 6x to the 5th power over square root of 1 minus x to the 12th power. We can multiply these exponents. So this right here is the derivative of cosine inverse of x to the 6th power. Find the derivative of 2 raised to sine of negative 5x. So here we have to use chain rule in the beginning, but we have to remember the exponential function derivative. So if I take the derivative of a to the x power, where a is just a number, we get a to that x times ln of that number a. But this is when argument is x. But here the argument is sine negative 5x. So we have to multiply derivative of sine negative 5x. So let's see. When I take the derivative of this function, apply this exponential rule, which is we just copy what it is and multiply by ln of 2. So up to here is same as this. But now here we have to multiply by derivative of this argument by chain rule. So we have to multiply derivative of that sine of negative 5x. So when we take the derivative of this one, we have to use chain rule again, right? Because argument is not just x. So let's copy this portion. Multiply by, now derivative of sine is cosine. So we get cosine of negative 5x, keep the argument. Now multiply by derivative of negative 5x. So derivative of negative 5x is negative 5. So final answer, we usually multiply negative number into the front because let me put it this way first. We're multiplying 4 different terms here, like this. Okay, multiplying. So multiplication order doesn't matter, so we can rearrange it to look better. So negative 5 times ln of 2 times 2 sine negative 5x times cosine of negative 5x, like this. So this right here is the derivative of this function. Make sure that cosine negative 5x is not in the exponent, right? Only exponent is sine negative 5x. Find the derivative of e to the sine x plus cosine x. So here, we take the derivative. First, we just get e sine x plus cosine x. Keep the argument, right? Then by the chain rule, we have to multiply the derivative of argument, like this. So then we get this portion stays the same. Multiply by, now derivative of sine is cosine. Derivative of cosine is negative sine x. So this right here is the derivative of this function. Find the derivative of sine of ln of x to the third power. So here, we have a composite function in a composite function. So we have to apply chain rule twice. But it's important to follow the correct order. First, we have to see that this entire thing, ln of x cubed, is argument for sine. So when we take the derivative, we have to treat sine as the outside function first. So derivative of sine is cosine, and keep the same argument, ln of x to the third power. Then we multiply derivative of ln of x to the third power because of chain rule. But now here we have to use chain rule one more time right here. So let's keep going. Cosine of ln of x to the third times, now derivative of ln x to the third, first is natural log, so it's 1 over the argument, multiply by derivative of x to the third. So next line we can write it, cosine of ln x to the third times derivative of 3x squared is x to the third is 3x squared. So 3x squared over x to the third, which this can simplify to cosine ln x cubed multiplied by, let's look at here, 2 of these can cancel out with 2 of here, so we have only 1x left in the denominator. So we have 3 over x. So this right here is the derivative of this function.